So today we are going to see which functions are not asymptotically comparable. It is not always necessary that we can compare two functions asymptotically. So which are the conditions when two functions are not asymptotically comparable? We'll see here. When two functions do not show consistent dominance over one another, then these two functions are not asymptotically comparable. For example, fn, one function is sin n and the other one is cos n. We know that these functions constantly oscillate between -1 and +1. Both of these functions are larger than another at different instants of time, not time, different instants of values of n. So these functions are not asymptotically comparable. They cross infinitely often without one eventually becoming consistently larger. For example, here one function is n plus minus 1 to the power n and other one is j n is equal to n. They are almost same, but for even n, fn is greater than jn, and for odd n, fn is less than g of n. Since the sign flip in many times, neither fn is big O of gn nor fn is big O omega of gn strictly O. So these are not asymptotically comparable. And here one function is n sin n and other is gn. Fn has different values one time for one value and other one minus n and one value is 0. The absolute value is comparable but not the actual function, so cannot satisfy big O omega or theta. Piecewise function for n is even, fn is bigger than gn, but for odd n, g of n is bigger than fn. So here we have short summary of two functions when they are not asymptotically comparable. When one function is sin n, other is cos n, they perpetually oscillate that while not asymptotically comparable. And when one function is n plus minus 1 to the power n and gn is cos n, switches dominance infinitely often. So these are not asymptotically comparable. When function is n sin n and other one is gn, changes sin n magnitude unpredictably. That's it. But if sin is in mod, then they can be asymptotically comparable. For piecewise function, different dominance on odd and even n. That's why they are not asymptotically comparable. So in CLRS book, I've seen one example where the author has written two functions. One is n and other n, one is n to the power 1 plus sin n. These two functions are also not asymptotically comparable. So basic idea is when two functions and are there and one is not show as one of them do not show consistent dominance behavior over other, then those two functions are not asymptotically comparable. Thanks.